Good evening, my dear friends and the entire student community. I hope you all wrote the GATE exam, that is GATE Electrical Paper 2022. All the hard work what you did for the last 1 year or so, I think today is the day which counts it. And I hope that everyone wrote very well. Now the agenda of this program is to have a general discussion of what sort of paper and questions came with the knowledge and feedback what we got from the students. Ultimately, yes, we will discuss about what sort of questions, the quality, the toughness on the paper. Myself, B.S. Krishna Verma, faculty in AC Engineering Academy since 2009. I teach primarily electrical circuit analysis or network theory, and I have got a very good experienced team with me. Ramesh sir, who is specialist in electrical measurements. I have Krishna Reddy sir, who is specialist in power system. I have got Rajendra sir, who is extraordinary man from power electronics. As a team today, we will be discussing about what level of paper and what sort of questions came in GATE 2022 for electrical sciences. As you know, our branch is one of the most dominating branch, and this discussion what we are going to have for another few minutes will be a definite guidelines to follow for the GATE 2023 students also. Now we will be going for accuracy, sir, but this analysis is based on the data what we got from our students who wrote just few hours back, and all the accuracy questions with data they are sharing with us. Very soon also, after this discussion and live session, in few more days, we will also come up with the accurate solution also. Okay, there will be a recorded video on accurate solutions also. But the agenda of this live show is to have a general discussion of what is the quality of the paper. Now, as you know, our electrical sciences, common subjects like network, control, analog, digital, signal, and we have core subjects like measurements, EMF, power system, power electronics, and machines. As every time, yes, approximately we do give the marks division. Yes, in our AC Engineering Academy, since last 30 plus years, we are specially trained for this, and we do share all the knowledge and the data with the student, because just preparing subject is not the criteria. What is the strategy? Which areas to concentrate? Which subjects are important? Okay, there is definite strategy, and the student who really catches this pulse will definitely crack the GATE exam in very first attempt. So my suggestion to all the students who wrote, and also the students who are going to write in future, please follow the strategy and the guidelines that we accurately share with our students. Now with the data what we got, yes, with the data what we got, which is almost, because so many students did give me reply in my WhatsApp, we directly call them. Now, as per the data, mathematics, we got 7 questions. Network theory, 5 questions, that is electric circuits we call. Control system, 6 questions. Analog circuit, 6 questions. Digital, 2 questions. Signals and systems, 4 questions. Measurements, 2 questions. Electrical machines, 6 questions. And the big things, of course, power system, very accurately we got 8 questions, and power electronics also 8 questions. So it is very clear that the core subjects are dominating. What are our core subjects? Yes, electrical machines, power systems, and power electronics. You see, power system and power electronics, 8 questions came. And we have a very good panel and most experienced teachers who will discuss what models came, which areas it covered, etc. And machines also 6 questions. So approximately 16 plus 6, 22 questions out of 65 came from our core. It is true, sir. Generally 24, 25 also it goes. So it is very, very clear that core will dominate. Then common subjects like network, control, analog, digital, etc. Shade, measurements also 2 questions we got. Now as a faculty from network theory, that is electrical circuit analysis, I have got some questions. I want to share with you the data. See, one problem came on dependent sources. Okay. Yes, one problem came on dependent sources with one DC excitation and 2 dependent sources, and is asking to find voltage V1 across the resistor. So it is such a simple problem, write a KVL. Now, because there are dependent sources, you know, extra link equations come. So one standard KVL and extra link equations based on the dependent sources, and the data showed we need to find the voltage V1 across the resistor. Okay, that is one of the question which came, which is hardly it takes less than 1 minute, and I would frame this question as an easy question. So the dependent source question in network theory based on a KVL and link equation. KVL, of course, we write the mesh equation, and link equation, linking the dependent parameter in the mesh current. Okay, it hardly takes 1 minute, so I categorize that as an easy question. Then there is another problem where he gave a switch. Okay, it was a transient problem, but he's interestingly asking steady state. Now this is the accurate data we got. Now there is a 10 volts DC source turning on a resistive circuit by closing the switch at t equal to 0. And he gave a RC circuit. But interesting question was, find the steady state voltage across capacitor. Now see this. He gave a switch, he gave a DC source. So it is a step response of first order RC. But what is the question he asked? He asked to find the steady state voltage across capacitor. He is not asking solution, so no need to worry. Generally, if it is a first order RC and state variable voltage, we write V of infinity plus V of 0 minus V of infinity. But here it is not necessary. What is the reason it is not necessary? Because he is asking directly steady state. Steady state is settled state at t tends to infinity. Now for the DC source, as the switch gets closed and t tends to infinity, we know capacitor acts as open circuit. Yes, when the capacitor acts as open circuit, I can easily write a KVL and find, and that answer also, yes, is so accurate, it is 5 volts. So from the data what we got, yes, it is 5 volts. And the third accurate question we got from the data of our students who wrote just few hours back is, it is a very, very standard question which already came in IES also and GENCO also. Let me tell you, sir, see, some questions do repeat. The data is similar. He gave quality factor of inductor and quality factor of capacitor, and both are connected together, and is asking the combined quality factor. And this derivation also we do in our ACE Academy, sir, in our standard notes. Since last 11 years I am teaching here in ACE. It is a standard formula that the combined quality factor of a circuit interacting both inductor and capacitor is Q total will be QL/QC by QL plus QC. So there in the data, which is so accurate we got from the students, at least 3 students gave me this question with correct data. QL is 60 quality factor and QC is 240. Okay, and the combined quality factor is what? QL/QC by QL plus QC. So 60 into 240 by 60 plus 240, it is going to be 240 by 5. So the quality factor is 48, and this I teach every year in my notes. Even in Google you get my notes, you see these are standard questions. Okay, so one dependent source problem, very accurate data we got. One transient based, but he asked a steady state, and one this. And there is a tank circuit also, sir. The data we did not get accurately, but he asked again their quality factor. So there was a second question on quality factor, but it was a practical tank circuit. Okay, but as the data comes, we will also put the accurate solution. So overall, out of 5 questions, network theory 4 questions, we got the accurate data, and very soon, as I told, we will also publish the solution. Now, I would like to pass on this discussion to my colleague Mr. Ramesh, who is specialist, and we will also discuss the remaining subjects. Okay, Ramesh sir, please, can you take over?
Right. This measurement subject, according to the data what we received, one question present from the bridges. In these bridges, the question is given with respect to the combination of 2 topics. One is error analysis and one is bridge balancing condition. So therefore, this question combinedly covers 2 topics. One is error analysis as well as bridge balancing question. As all of you know, in the 4 branches will be there in the Wheatstone bridge. Out of 4 branches, 3 branches data they have given, and they are asking one branch other branch value. The 2 under balanced condition. Everyone knows that opposite branches multiplication should be equal to other opposite branches multiplication, but in this the branch impedances, branch resistances are given in percentage error form. That's why after getting the equation from balancing condition, we need to follow the error analysis theory. What is that error analysis theory? If you are multiplying 2 parameters, which errors must be concentrated? Percentage errors must be concentrated. And if you are going for division operation, percentage errors must be concentrated. Therefore, in the given data, according to the memory based data, we received the data given in percentage errors only. So we can proceed with the as it is data. But in the options they have given error in the form of value form. Error in value form. Therefore, finally, after getting the result in the percentage form, we need to convert the percentage into value form. And these models of questions, we have solved so many questions in the classroom, and same model is being repeated. So this is generally 2 marks question. Maximum 1 minute time is sufficient. So this is the question we received as of now based on the memory data. Now I'm passing to the next faculty.
Hi, from power systems point of view, as per the data that we got, we received 8 questions. Okay, so if you observe these questions that are memory based students which we have shared, so one question was given from economic aspects. Okay, it is very easy, and that we have already solved in expected questions also, that the video we have shared previously. Okay, so he has given the fuel cost equations and he is asking to find the powers of the generators, and the other question was asked based on GMR calculation. Okay, and coming to the another question, what he is asking is which relay is used for protection of alternator against loss of excitation. So this question we have already discussed in the classroom, direct question. Okay, so which relay is used for protection of alternator from loss of excitation? That is nothing but offset Moore relay. And the other question that we have observed, he has asked regarding the calculation of angular acceleration. Okay, for calculation of angular acceleration, this question is also direct classroom objective type questions that we regularly solve in the classes. Okay, so from using the swing equation, by using the swing equation we can directly solve this. Okay, and one question we have observed from cables. Now I request Rajendra sir to continue.
Yeah, thank you, sir. Hello, everyone. The first thing is I am very happy today because comparatively for the power electronics, the weightage is very good. They have asked the 8 questions and the weightage is around 10 plus marks. If you check a last year question paper, there was a weightage of 9 marks, but this time it is a 10 plus marks. Okay, so and if you check the difficulty level of the questions, it is a easy to moderate. Okay, hardly I think one question will be up to the hard level. Okay, but most of the questions will be the easy to the moderate level. So let me summarize it. On the power electronics, there were around 8 questions. The weightage is 10 plus marks. In that, we know we are having a total chapters like first one is the switching devices and remaining are the converters. On the switching devices, there was a one question. They asked a very straightforward question. We are going to discuss that even. There were 3 questions on rectifiers. So friends, this is a very good point. And if you check for the rectifiers, yes, comparatively the difficulty level is a moderate to easy only, right? There were 2 questions from DC to DC converters and 2 questions from the inverters. Okay, so roughly around 8 questions were there. So let us discuss one by one. One more important thing, the last chapter, that is the AC to AC converters. Okay, as per the we can say the tradition, right? They have not asked any question on this year also, right? So let us start with the questions. Yeah. Yes. Yeah. So let me read the question first. This question is related to the single phase full bridge diode rectifier. A single phase full bridge diode rectifier feeds a rectifier resistive load of 50 ohm. Simple, we are having a load is a purely resistive and single phase full bridge diode rectifier from a 200 volt 50 hertz single phase AC supply, right? RMS value of the supply is given, it is a 200 volt and the supply frequency is a 50 hertz. If the diodes are ideal, then the active power is, okay, diodes are ideal. Means we know if the diodes are ideal, that is the switches are ideal. So therefore the power loss in the ideal switches are definitely 0. So here can we say that the input active power is nothing but the output power, right? And for the purely resistive load, how to find the power consumed by the load? Yes, we know it is a V0 RMS square divided by R or I0 RMS square into R, or we can say V0 RMS into I0 RMS, right? So a single phase full bridge uncontrolled rectifier, purely resistive load, and from the given data, yes, we can write P output is equal to P input, and we can write which is equal to V0 RMS square divided by R. We know very well how to find the purely resistive load, right? And after doing the calculations, we will be getting it is like a V0 RMS is equal to 200. So it is a 200 square divided by R, that is a 50. So it is equal to 800 watt, right? So correct answer is 800 watt. This answer I am telling based on whatever the data and the figures received from the students. Okay, right. Next question. Yeah, let me read it. Yeah. Charger supplies 100 watt of 20 volt for charging the battery of laptop. The power devices used in the converter inside the charger at a switching frequency of 200 kilohertz. So they have given a very high switching frequency. Which power devices, yes, is suitable? Which power device is suitable for this purpose? And they have given the options. One is a thyristor. Second one is a Mosfet. Obviously, Mosfet means a power Mosfet. Third one is the IGBT, insulated gate bipolar transistor. And the last one is the BJT, that is a power BJT. So friends, if you check in this question, they have given a laptop charger we are having. So it is like we are having single phase AC supply as an input. It is given to the rectifier circuitry. And the output of the rectifier is given to the DC to DC converter. So my dear friends, please be careful. Here they have given the switching frequency is a 200 kilohertz, right? So those switches, they have asked about the switches which are present in a DC to DC converter, right? And for 200 kilohertz, which is, we know it is a power MOSFET only, right? So correct option is a power MOSFET, right? So this is about the second question. Difficulty level, if you check for these two questions, yes, it is a easy only, right? Next question is related to the single phase semi converter. Very straightforward question. We have already discussed multiple times, right? Fourier series expression of source current waveform in the case of single phase semi converter. And they have asked the RMS value of fundamental component of source current. So here single phase semi converter, they have asked the IS1 RMS. It constant and its amplitude is a 15 ampere. So I0 is equal to capital I0, which is equal to 15 ampere. Alpha is also given. Alpha, that is the firing angle, which is equal to 45 degree. So we know IS1 RMS, we can write it is a 2 root 2 divided by pi into I0 into cos of alpha by 2. We have derived this expression during our classes, right? During our offline classes or recorded video sessions or the even live batches also, right? So if you check the answer for IS1 RMS, it is a 12.476 ampere. Okay, again I am saying this is based on the data whatever we have received from the students end. Okay, so this is the third question. Next question, yes, the difficulty level for the next question is a moderate. This question is from AC to DC rectifier. AC to DC rectifier. Very straightforward question. I would like to add here, even in our classroom practice questions, we have solved these type of questions, right? So let me read it. The types of the voltage input to AC to DC rectifier V is equal to 230 into root 2 into sine of omega t. Omega is equal to 2 pi into 50 and current I they have given is equal to 10 into sine of omega t minus pi by 3 plus 4 into sine of 3 omega t minus pi by 6 plus 3 into sine of 5 omega t minus pi by 2, and they have asked the input active power. So here if you check in the source voltage expression, we are having only fundamental component, yes or no? Frequency of the fundamental component is omega, and whatever the current expression they have given, in that we are having a sine of omega t, sine of 3 omega t and sine of 5 omega t. So can we say that the source current consists of fundamental component, third harmonic component as well as fifth harmonic component, right? But the source voltage is only fundamental because it is a pure sinusoidal they have given. So how to find the input active input power? Yes, it is a product of RMS value of the fundamental component of the source voltage into RMS value of fundamental component of source current into cosine of angle between fundamental component of source voltage and fundamental component of source current, right? Here the third harmonic component and the fifth harmonic component of the source voltage is 0. So therefore, if you find the input power, that is the active power input corresponding to the third harmonic component and the fifth harmonic component, you will be getting 0. So whatever the input active power is nothing but power due to the fundamental component, that's it. So here fundamental component RMS voltage is equal to 230. Peak value is the 230 into root 2. For any sinusoidal we know na, RMS value is equal to peak value divided by root 2. So means it is a 230 volt. So RMS value of fundamental component of source voltage is a 230 volt. What about the RMS value of fundamental component of source current? Peak value they have given it is a 10. So RMS value will be 10 by root 2. So can we write it is VS1 RMS, that is 230 into what about the cosine of angle between IS1, it is a pi by 3 they have given. Okay, so straightforward here we can write 230 into 10 by root 2 into cos of pi by 3. So if you simplify it, we will be getting it is a 813.17 watt. Okay, we have already of questions. Even we have during our classroom sessions address the issue like suppose if the source voltage is also having a harmonic component, that is the third harmonic component, then how to find the active power input. Okay, so this is a moderate level difficult question. Next question, yeah, this question is from DC to DC buck boost converter. Okay, buck boost converter. So in that they have given a inductor current waveform. It is like a decreasing, increasing, decreasing, increasing type of waveform they have given. The peak value of inductor current is a 16 ampere, right? That is a I max, and a I mean is equal to 12 ampere. Means inductor current is changing between 12 ampere to 16 ampere, 16 ampere to 12 ampere, again 12 to 16, 16 to 12 like this. Okay, and they have given DC to DC buck boost converter. Peak to peak output voltage is 1 volt, that is a delta V0, which is equal to delta Vc. They have given it is equal to 1 volt. Value of output capacitor in microfarad is, means our task is to find the capacitor C value. Which converter they have? It is buck boost converter. So my dear friends, first of all, can we comment on whether the conduction is continuous or discontinuous? Yes, from the waveform of inductor current we can say that it is a continuous. Yes or no? So conduction is a continuous conduction only, right? Now for the given IL waveform, can we write the IL average? Yes, we know when the inductor current is changes from I mean to I max and again decreases from I max to I mean. How to find the IL average? It is a I mean plus I max divided by 2, right? So here minimum value is 12 ampere, maximum value is 16 ampere. So what is the average value of inductor current? It is a 12 plus 16 divided by 2, right? So it is a 14 ampere. Okay, so IL average you will be getting it is equal to 14 ampere. Next, how our task is to find the on when switch is in a on state. Recall the circuitry buck boost converter. Okay, when switch is in a on state, inductor go on storing the energy na, and capacitor discharges. So during 0 to t on we are having IL is inductor storing energy. So IL will be increasing, right? So here we can write C is equal to delta Q by delta V0. In that delta V0 they have given. The only thing is we need to write the delta Q value. How to find the delta Q value? We know the area angle where the rectangle is present in the IC waveform. Okay, so we can write delta Q is equal to I0 into dt. dt is nothing but the on time. So I0 into on time divided by delta V0, that will give you the capacitor value. But here delta V0 they have given. So we need to find T on and the I0 value. Then and only then we can get the capacitor value. So how to find the T on? Check the waveform of inductor current carefully. Here they have given corresponding to the 20 microsecond inductor current is changing from 12 ampere to the 16 ampere. Inductor current is increasing from 12 to the 16 ampere, means inductor is storing the energy. And we know, recall the operation of the buck boost converter. When switch is in a on state, inductor stores energy. So can we say that corresponding time 20 microsecond is your turn on time, right? Second thing, corresponding to the 30 microsecond they have given current is decreasing. So when current decreases, it indicates that inductor releases energy. So here can we say that turn off time is equal to 30 microsecond. So T on is 20 microsecond, T off is 30 microsecond. So what is the total time T? It is equal to 20 plus 30, that is equal to 50 microsecond. And from this we can find the duty cycle D also. Okay. So now D and dt we can find. Okay, the only thing is we need to find the I0. So for buck boost converter continuous conduction, what is the relation between IL average and I0? We know IL average is equal to 1 upon 1 minus D into I0. IL average we have calculated, duty cycle we have calculated. So from this we can find the IL, we can find the I0. Once we get the I0, we can get the value of capacitor C. So after simplification, I am giving you the direct figures. We will be getting I0 is equal to 8.4 ampere, duty cycle D is equal to 0.4, okay, and if you put these values, then we will be getting C value is equal to 168 microfarad, 168 microfarad, okay. So again I am repeating, these are the answers based on whatever the values of the figures given by our students, okay, because those are the memory based questions only, okay. And I would like to rate this question as a moderate level question, okay, moderate level question. So these are about some of the questions whatever we have received from our students related to the power electronics, right. Now I would like to hand over to the Verma sir.
Yeah,
Sir, please.
as the data we are getting, the more accurate discussion we will have with you. Now that is what you got an elaborated and good explanation from our power electronics teacher Rajendra sir. So we are still getting lot of data shared by our students. As we go to the next round to discuss few more subjects and have lot of balanced way of thinking to what to study and what not to study in future for my students, we will take a short break for 2 minutes and we will again join with the next round of subjects. Welcome back to this live discussion on GATE Electrical Engineering 2022 paper. See, until 2 days before, we were having the tension whether Supreme Court will postpone the exam. Even I was so tense that most of my students keep calling me WhatsApp, sir, will the GATE postpone? But see, our government took such a great decision. We are going ahead. And what Supreme Court ruled it? Yes, we cannot take the risk of the careers of the students. Yes, IITs do maintain this quality, sir. Okay. Now, with the recent poll, yes, the live poll, what we are getting, most of the students suggested, yes, the paper, 50% of the students who wrote electrical, they suggested the paper was moderate. 23% told it is difficult and 26% is easy. Yes, that is what is the real thing. Yes, 50% told moderate, 23 difficult and 26% told easy. And as the more and more data we get, we will share with you.
Varma sir, when compared to previous year's GATE exam, so how do you feel these questions?
Yeah, see, as my friend Mr. Krishna Reddy asked me this question, I think overall, when compared to last year, the balance in marks is good. What I would say is the core subjects really dominated. That is a good thing that everyone should understand. As electricals, you know, even my favorite subject is machine, for example. Though I am a teacher here in networks, my favorite subject is machine. The core subjects are dominating, like machines, power system, and power electronics. They came 8, 8, and 6 marks. So, and moderate level. So, rather than I can say easy or difficult, moderate level, that is true. And 2 to 3 questions should be difficult because the quality comes when these difficult questions are coming. And the real difference between a topper and an average student also will be determined by this. So, sir, according to me,
as per your experience, topper will score how many marks?
my guess, yes, I would say this time because overall paper 50% moderate, I would guess 80 to 85 should be a topper mark who want to get admission into IITs and IASC. That is my estimation. It is all based on that discussion what we are having. 80 to 85 should be topper or maximum 87 marks.
What about you, Ramesh sir? What do you think about this?
Yeah, according to the paper, just we are expecting that around 85 marks means 85 plus or minus maybe the topper score.
Rajendra sir, what about your opinion?
Yeah, according to me, if you check last year, the topper marks were I think around 90 something, but for this paper around 85 to 87 will be the topper marks. Right.
So this paper is having more weightage from technical, that is core areas.
Yes.
Okay? When compared to last year's,
Yes.
this year core areas are concentrated more.
Yes, that is true, sir. That is true.
Right.
That is what is the good thing that
Good thing.
our as electrical, machines, power system, power electronics, we have the passion. Though common subjects are more or less like signals, analog, digital, they are equally important. I never say no. The students who are again preparing and especially 2023 students who are attempting, understand, sir, it is a very balanced paper, but definitely dominated by core subjects. But we cannot see to learn core subjects also. What I suggest always, our fundamental subjects are important. So network, analog, digital, control, okay, signal, measurement. See, first preparation standard point of view, we need to cover first fundamental subjects. Directly going into power electronics or power system and machine, without fundamentals of these basic subjects, we cannot go there. So preparation strategy wise, always first read network, control, analog, signal, etc. But balance the time and you spend more time, okay, more time on core subjects. So even for GATE 2023 students, what is our suggestion? Yes, by August you should prepare fundamental subjects. And from August you should concentrate on core subjects. And MTech subjects are also the core subjects. Okay, that is what my estimation on this.
Right.
And then, now sir, as we already got a detailed discussion on 3 subjects, sir, we will also go with few more subjects here with the data what we got. Now in control system, there are total 5 questions, okay? But we got the data of 2 questions very accurately as of now. But as I told sir, these are estimated rough data, but some of them repeated multiple times by some of our students, so I could also say they may be very accurate. But as I told, in few more days, okay, we will also come up with accurate solutions in detail in our YouTube channel. So do please subscribe and watch these solutions. But once the data is confirmed accurate, we will have the solutions. Okay. And as you know, the result will be expected on, yes, March 17th. You know that, right? Now in control system, out of total 5 questions, now I got the data of very accurate data of 2 questions. And in one question, the question was the open loop, okay, transfer function of a unity gain negative feedback system is given by G of S is equal to K by S square plus 4S minus 5. The range of K for which system is stable. Now after time domain analysis in control, the moment we start frequency, especially root locus, root Hurwitz, etc., this is the fundamental question is asking the value of k gain for which the system is stable. What we do, sir? Root Hurwitz, you remember? We take a column, right? Yes. Though I am not a control system teacher, but I share a fundamental knowledge like you as a student. Okay. Now, based on that, it is so easy that we write the root Hurwitz, and from that, s square coefficient is 1, s coefficient is 4, and s power 0 coefficient is k minus 5. Now, you know, there should not be any change in sign as we go. Yes or no? The number of sign changes indicate number of roots on the right hand side. That is unstable. So clearly, if s square coefficient and s coefficient is positive, then s power 0 should be positive. So k minus 5 should be greater than 0. So k is greater than 5. Greater than 5. This is an accurate answer and data we got. Then another thing we got, yes, is based on block diagram, or I can say signal flow graph related. The damping ratio and undamped natural frequency of a closed loop control system he gave. Yes, it is having a multiple loop feedback. Okay, G of S is 10 by S and another 10 by S. And now he is asking the zeta value, that is damping ratio and also natural frequency. Now after taking the closed loop transfer function C of S, that is by RFS, we get something like 100 by S square plus 10S plus 100. Yes or no? So 100 by S square plus 10S plus 100. And from the characteristic equation, it is very direct that omega n is 10 radians per second and zeta is clearly half. So these are the data we got. And 3 more questions as we get the data we will share with you. Okay. So these are the 2.
Very easy, sir. From
control system also direct based on formula. That is what
our classroom objective type questions that we regularly
solve. Yes, Krishna Reddy sir, that is true. Yeah. See, the questions as I told are directly based on formula, but the more accurate data we get, we will share with you. Now I would like to pass on to discuss few more subjects to my Ramesh sir. Ramesh sir, please go ahead.
Yeah, coming to analog electronics, as of now we have received 4 questions. Out of those 4 questions, 2 questions are based on operational amplifier, and 1 question is based on Mosfet, and other question is based on Diode circuit. And if you see the questions from the operational amplifier, there are 2 questions, and they have given that one operational amplifier circuit, and he has given options output impedance Z out, frequency, both related graph has been given, and what was the relation they have given. This is 1 question. And other question based on the operational amplifier is current gain he is asking. So based on the current gain means direct formula will be there. And option they have provided is minus CF by CC or CC by CF or minus CC by CF or CF by CC. Means he is asking the capacitance by capacitance ratio, current gain he is asking. And coming to MOSFET question they have given. For ideal MOSFET based biased saturation, the magnitude of the small signal current gain for a common drain amplifier he has given. One ideal amplifier they have given MOSFET, and based on that the question options are given as 100, 1, infinity and 0. This is direct question. And coming to back-to-back connected reversely, and one resistance is given, and across the entire circuit input supply is given, and across the resistor output voltage they are asking. And the options they have given that input voltage and output voltage relation when input voltage is greater than 0 or less than 0. So totally like 4 questions are there, and if you are looking at these questions, almost 2 questions are directly conceptual, 2 questions are based on the formula base. So therefore we can say almost moderate questions. Now electronics. In the digital electronics, as of now we have received 2 questions, and 1 question is based on the counters, mod 2 and mod 5 up counter based. He has given 1 question, and 1 more question is counter based. 1 more question is given, and that is
compared to previous years, this analog and digital are also very easy. Fundamentally, they are stressed.
yes.
Okay, previous gate they are going to complex circuits, but if you observe these papers,
Very simple
questions.
And again, I want to repeat this, my dear friends and students, that it is based on the data and the feedback we are getting. Okay, maybe some of the values may not be accurate, but the models are true. So as we get the accurate proof and data, we will also share. But yes, this is the data shared, and we are very good that so many of our students do reply to us. They also gave the same rating, sir. It is an overall moderate paper. like as Ramesh sir was telling that analog digital also, they are very simple bits. Okay, though you are, see, as electrical, we always concentrate on core subject, as I told you, but don't neglect these easy subjects. So they take less time and they give more marks. See, my simple analysis to these basic fundamental subject like control, analog, network, digital, they take less time but give more marks. Of course, your MTech subjects, core subject, they take a lot of time and that is important for us throughout our life. But these subjects, yes, they give more marks in less time. So do concentrate and always have these fundamentals. Okay. What do you say, Ramesh sir?
Yeah. Compared to previous paper and this paper will be little bit more and last a little bit more difficult questions were there, but now it is almost easy to moderate questions were there in analog as well as digital subjects. By Krishna Reddy sir.
Coming to the one more important subject that is machines. So here we have got 6 questions. Okay. So in that one question is from synchronous machines. A star connected 3-phase 400 volts 50 kVA 50 hertz synchronous machine. He has given the synchronous reactance and he has given loss in the motor is 2 kilowatt and he is asking to calculate the excitation EMF. So this question we have already solved. This model, okay, numerical may be different, but this model of questions we are already solved in our classroom objective type questions. Okay. So if we observe, the level of the questions are very moderate. Okay. So we can expect our students will crack the rank this year.
Yes, I am expecting a lot of A students will be as toppers because most of them are being discussed with you and in the class, whether it is a live class or offline. Offline also we had only 2-3 batches because of Corona, etc. But still, most of them opted for live and deep learn. Yes, of course, deep learn was very successful, and our strength, we were really fortunate to be working there as a team. And in deep learn, we were the first in India to launch all the subjects. Let me tell you. Yes, in India, ACE Engineering Academy Deep Learn, now it is called ACE Online, of course. We call it as Deep Learn, it is called now ACE Online. We were the first in India to launch all the subjects, let me tell you. Okay. So yes, we got tremendous response and all these fundamental models, basic models, we do and we did discuss. What do you say, Rajendra sir, on this?
Right. Sir, I would like to add one more point.
Yeah.
2 questions were received from students related to the induction machines. Okay. So, strictly speaking, those are very straightforward questions. Okay, let me read it. The frequencies of stator and rotor currents flowing in a 3-phase 8-pole induction motor are 40 hertz and 1 hertz, right? So stator current frequency they have given 40 hertz and rotor current frequency is 1 hertz. The speed of the motor in RPM is, it is a very straightforward question, right? So how to find the speed of the motor, that is a N. So here first thing is they have given the rotor frequency, that is a F dash, rotor current frequency, and next the stator current frequency, it is a F. We know F dash is equal to S into F. So from this we can calculate the slip, which is equal to 0.025, and from that slip we can find the actual speed of the rotor or motor, we can say. So it is equal to, we'll be getting 585 RPM. This is one of the question. It is a I would like to rate this as a easy question. Next question is related to the single phase induction machine. The type of single phase induction motor expected to have maximum power factor during steady state running condition is. So here they have given during steady state running condition the maximum power factor, and the options given are shaded pole, capacitor start, split phase, capacitor start and capacitor run. So very straightforward question here. If we want a maximum power factor during the steady state running condition, yes, the motor should be a capacitor start, capacitor run type of motor, right? So option D is the correct option, right? So these are some of the questions related to the induction motor. Let us have some discussion on is there any newly added area or untapped area, we can say, right? Specifically this year's gate examination they have added or asked the questions, okay?
Yes.
But previously there were
Now in
no
signals,
questions.
yes, that just now we got the data that signals out of 5 questions I announced. In the 2 we got, okay, in the 2 we got. But as Rajendra sir was asking, is there any newly added area? Yes, this time discrete Fourier series was the latest question, which did not happen in the last few years. So signal, don't neglect, sir. Though we are all electrical in BTech, unfortunately, signals and system is not being taught for us. But when you go to industry, let me tell you, when you go to industry, there is no difference between a communication engineer or a power engineer. They work together. So when you go to DRDO, ISRO, okay, they need a lot of mathematical background from signals and systems. So this time I feel this bit which came on discrete Fourier series is a moderate question, and I think it is a new area. But when compared to other subjects like even my subject network, or you talk about controls, they are standard areas. So I overall say maybe 1 or 2% according to me. Maybe they would have got extra, but overall it is a very predictable, easy paper. Now as I conclude this signals also, one more question was so easy. He was asking by giving a function like y of t is equal to x into e power t. He is just asking whether the function is linear causal, linear non-causal, non-linear causal, non-linear non-causal. Now this function, you see, it is y of t is equal to x into e power t. Now if you check linearity is homogeneity and superposition theorem. Like if x1 yes, it becomes x1 e power t1 or t, and if I give k1 scaled by k1, okay, into x1 is k1 x e power t. Similarly, if I give another input x2, it is x2 e power t. If I scale it by some constant k2, it is k2 x2 e power t. So it is absolutely linear. Okay, one thing we can see easily, it is a linear system because their homogeneity and additive property is observed. But what about causal or non-causal? Now see, this function x into e power t, that means the function value depends upon time. Na? Obviously the function value, suppose you put t equal to 1, it becomes e power 1, t equal to 2, e power 2. So it depends upon time. So it is non-causal. So the answer is linear and non-causal. Okay. So these are the just 2 questions we just now received from our students. Okay. So that is what I would like to say, that we covered more or less all the subjects. And in maths, yes, we are still getting the data, but in maths overall, there are 7 questions. Okay, 7 questions. They are in that the feedback is yes, 5 questions are easy and 2 questions are moderate. That is what we got the data. And as you know, English and aptitude, you would have known it. So that way, I would overall say the general discussion on this gate paper. Okay, and I would like to ask my colleagues, sir, now tell me, like what you say, this year gate 2022 paper. Okay, sir, overall, okay, easy or moderate or tough?
The student of ACE can easily crack this exam because most of the questions are discussed in our classroom sessions and our classroom objective type questions that we give. So it is moderate from my point of view.
Okay, what do you say, Ramesh sir?
Definitely it is comparatively, last year etc. we have compared, definitely this paper is generally moderate only, so everyone can score well.
Right.
Okay. What do you say, sir?
Yeah. By observing all the questions from all the subjects, yes, we are having the weightage or the difficulty level is around moderate only, right?
Okay. So I would go in a little bit contradictory way. I would say it is overall easy compared to last year. See, my initial guess was after getting all the data and as we are getting more and more questions, what I find is majority of the questions are straightforward. And the student who took coaching here and whatever notes we gave, whatever data we gave in deep learn, etc., you follow that is more than the required standard. So what I feel compared to last 3 years, what I am seeing, even my network questions also, they are damn easy.
Mostly
because
they are basics.
Yeah,
Right,
basics.
right.
Even I thought it is a transient question. After seeing the data, I thought it is a transient question, but see, is asking steady state. So that way, they are absolutely easy. Overall scoring will be very high, but still I expect, yes, 87 will be 87 plus also. It can be even
Right,
87
right.
plus will be the score of topper easily, and it may cross 90. Who knows?
Yeah.
There may be so many students, preparing fantastic, and I hope it may even cross 90. But overall, 80 to 85 is a very good score to get into, IITs and do MTech, okay, and also PSUs. Yes, that is my, prediction there overall. So with the feedback again, yes, I would like to share with you. Most of the students are again saying it is moderate. Yes, the poll has slightly increased. It has gone more. Now I say it is moderate. Most of the students are saying moderate, and also easy more. Difficulty only less. It went down. Difficulty percentage went down.
Right.
So overall, I would say now it has reached almost 57% students are saying moderate. Okay, and difficulty now it has gone down to 19%. So that is where that shows your preparation. See, one good way to argue this weightage or this classification is the preparation standard. So more or less, as you know, our ACE Engineering Academy is one of the leading institutions in entire India since 1995. Okay, the root level, sir. We have got so many faculty. We are just, after all, 4 members. I'm telling you, our team is more than 40 in electrical science. Okay, most of them are there. They are quite busy, etc. But still, we have got a quite big team in Department of Electrical Engineering. and we would just like to share, and more information come, we do definitely like to share with you. But understand, our material is also very accurate. See, what do you say about our material, sir? See, when you compare, see, it is done by our ages. Like I was a student of ACE Academy. I remember those days, VM Rao sir, so many legends who did teach me, and I am a student now, and I am a teacher now. There are so many students now. Like even my Rajendra sir is also a student of our Seshe sir, etc. Yes. Mala Reddy sir, okay. What sir? We are all there here. But compared to the legends, yes, we have got a big team, and our material is the most accurate, let me tell you. Even a student who stay at home, after listening our videos, either deep learn or live, just follow our material in notes, and that will be enough to get very, very good score, and you will get definitely into top 100 rank, okay. So that is what I would like to say, sir. Any further information?
Followed our deep learn classes.
Yes.
Yeah, they are benefited during this COVID situation. We have not gone through offline classes, but we have provided the online classes.
That is true, sir. Because when I remember, like in 2020, when Narendra Modi ji kept a lockdown, we thought our business is gone. Yes, we do business, our coaching center. The main thing is preparation strategy. We were very quick to respond by June. I think April, May, June. By July, we started deep learn. And of course, these live batches also were there. But deep learn we launched immediately with so many subjects. Some subjects took time because of COVID. So many faculty could not return to Hyderabad, etc., etc. But we did our best. And today I can say that deep learn is one of the best, tool, or you can say digital learning platform, where we are even upgrading it version 2, version 3. As and get, we are adding more and more tools to it, okay. And we are having best faculty in India in ACE Engineering Academy. Okay, we look forward to it, sir. And very soon we would also, give the accurate solution, recorded video or live video very soon, that we will announce to you. Okay, please subscribe our channel and do register. And also all the students now who did preparation for last 1 year, I think you are really tired, right? But don't be tensed. You know in your heart how better you learned and how better you performed. But take it as a challenge, and failure should not be a thing to discuss. And I hope all the students who sincerely prepared, and they will be going to very good, successful path. At the same time, the students who could not get good score, take it as a challenge, sir. We are always there to support you, technically, morally. There is always a path to improve, and do again register and join our ACE Engineering Academy, or even you may not join. We are always there to help you. Okay, so that way we will look forward to you, and happy day to enjoy. Now at least tomorrow is Sunday. Take relax. Don't worry much about the score and marks, but definitely accurate solutions we will come with you very soon. Okay, so bye from our team. Okay, thank you, and all the best.
Thank you.